Alright, so good thing we weren't recording the last 25 minutes. You know? Okay. Alright, so last of the four conic sections today. Hyperbolas are probably the most involved. He's saying the other I dropped that out. They're probably the most involved ones of them, but you know all the stuff already that goes into them. Okay? So they have the most stuff to go along with them, but it's a combination of everything that you've done leading up to this point. Okay? Alright? So, let's first describe what a hyperbola is. Okay? Some people call it an inside-out ellipse. Okay? Which I don't really like because I just don't like it. You know? But formally, a hyperbola is for any point that is on the hyperbola. It is the you take the distance to the two foci and you subtract them, and that's the constant. Okay, so in an ellipse you added, it was the sum of the distance to the two foci. And that made the ellipse. In a hyperbola, it's the difference. Okay? So you take the distance to the first foci minus the distance to the second foci. Okay? And that difference is a constant. Now, the downfall with hyperbolas is there are two different kinds. Okay? There's a left and a right hyperbola. There's an up and a down hyperbola. And we'll get into these equations here momentarily. Okay? How you go about making a hyperbola is actually relatively simple. There's a lot of intricacies involved in it, but again, you know all of them already. Okay? But what you do is you build this box around the center. Okay? And then from that box, you draw in the two diagonals, and those are the asymptotes. So it kind of forms the hyperbola for you by drawing in those asymptotes. Okay? And then the foci are inside, just like for the parabola, the focus was inside. For the ellipse, the focus was, the two foci were inside. For a circle, the focus is the center, so that's inside. So the focus is always inside the conic. Same thing here. So it'll be inside the actual conic, outside of the box. Okay? So, let's dive right into the equations. Okay? So, as I said, there were two different kinds of hyperbolas. Okay? So, what you have to look at is you have to look at which variable, which squared variable is positive. If the x squared is positive, it's a left and a right. If the y squared is positive, it's an up and a down. What do you mean positive? Well, see, because we're subtracting. So who's there? So really, this is minus y squared. Okay, so it's negative. Okay, so y squared is negative. And on this bottom one, it's minus x squared. So x squared is negative. Okay? Or if you prefer, you look at which variable comes before the subtraction sign. You know, if x comes before the subtraction sign, or if x squared, comes before the subtraction sign, that's left and right. If y squared comes before, up and down. Okay? Notice how a squared stays with x squared. Okay? And b squared stays with y squared. Which is good, because then that's all the same from ellipses. We had a squared underneath x squared in an ellipse. We had b squared underneath y squared. Okay? So we have it set up for you so that all of the stuff that you've learned now kind of gets all mashed potatoed into one. Okay? Some examples of ellipses, of hyperbolas. Okay? My favorite one is the lamp. If you got a lamp with one of those fancy lampshade thingies on it, okay, and you have the room is totally dark, okay, and you turn that lamp on, you will see like the top of the hyperbola above, and you'll see the bottom of the hyperbola below on the wall. It's pretty sweet. Okay? Pretty sweet. That's my favorite one. Okay? A sonic boom is a hyperbola. Okay? Or it's half of a hyperbola. What else we got? The planetarium in St. Louis is in the shape of a hyperbola. Radio signals and triangulating where radio signals are going, and that's all hyperbolas. Hourglasses, the hourglass figure is a hyperbola. Yeah, all right. Let's do this, man. Yeah. So here's our hyperbola. We're going to graph that bad boy. Okay? So x minus 3 quantity squared over 9 minus y plus 2 quantity squared over 16 is equal to 1. Okay? The very first thing that we have to do, and even before we get into the steps of graphing it, we should figure out if this is a left-right or an up-down. Okay? So, based upon the two formulas that you just wrote down, is this a left-right or an up-down? It's a left-right because the x part, or the x squared term, comes first, or because we're subtracting y squared. Okay? So this is a left and a right. So this parabola is going to open to the left and to the right. Okay? So we determined that this is a left-right hyperbola. Next, what do you think we're going to do? Find the center. Okay? Yep. So the next thing that we're going to do, just like before, we're going to find the center. Okay? So where is the center of this hyperbola? 3 comma negative 2. Okay? Both are in a set of parentheses, so we think oppositely on both. So the center of this one is at 3 comma negative 2. Okay? And that point we can graph on our Cartesian coordinate system. 3 comma negative 2 is right there. I'm going to put a C there. Okay? Now what we do is we are going to build that box. Before we can draw our hyperbola in, we've got to build that box around our center point. Okay? So I look at the number underneath the x squared term. Okay? And I say, well, that number is 9. I'm going to take the square root of that number, which is kind of like what we did in ellipses, right? And then I'm going to go left and right from the center. That many. So the square root of 9 is 3. So I'm going to go left 3 and right 3. But the difference is, now because we're building a box, I'm going to draw walls in over there. And I'm going to do it lightly. Okay? I don't want to do it fully dark because I want to do it light because I want to be able to see my actual hyperbola. Okay? So right there, that's all I know yet because I don't know how much I have to go up and down yet. So I'm just going to put little ticks over there as to where the left and right sides are. Okay? So let me get us back here now. So we had a center here, we had a wall there, and a wall there. Okay? Now I'm going to look underneath the y term. Okay? So that's going to be 16, or the y squared term, I should say. That's 16. Take the square root. Square root of 16 is 4. So I'm going to go up 4 from the center and down 4 from the center. Okay? So now what I can do is now I can draw in that box. Because now I've got the top, I've got the bottom, I've got the left, and I've got the right. Now, let me see if I can do this. And then I want to go, oh yeah, look at that. Learning stuff. Okay, so then I made mine a little darker, or a little lighter, so we can't really necessarily see it like you have on yours. Okay, drew it in with nice and prettiness. Okay. Actually, we gotta go a little black blue. Oh yeah, I like that one better. Yep, it's all about. That's the transparency right there. Okay. Okay. So next, what we're going to do is jumped on me. Next, come on, is what we're going to do is we are going to draw in the diagonals of that box. And when I draw in the diagonals of that box, those are going to be asymptotes. So I'm going to draw them in as dashed lines. Okay? Like we did when we were doing, what's the word I'm thinking of? Rational equations. Okay? So there are the diagonals of my box, which are the asymptotes of my hyperbola. Okay? Now, let's take a moment here. I know it's not your favoriteest, but let's take a moment here to come up with those equations of those asymptotes. Okay? So, a couple of things that we have to do with that. First off, the slope of those asymptotes is always going to be plus or minus b over a. Always. Because from the center point, you're always going to go up b and over a. Rise over run. Okay? Alright? And so if I go up b and I go to the right, then that's positive b over a. If I go up b and I go to the left a, that's negative b over a. So the slope of your lines will always be plus or minus b over a. Okay? The other thing that you can do is, now in this particular case, the sides of our box were on the y-axis. So to make the equation of a line, I need the slope and I need the y-intercept. Well, I have both of those. Okay? So I can go right to the fact that the equation of the first line is y equals positive 4 over 3x. That's the slope. So my positive slope is this one right here. So that gives me a y-intercept of negative 6. So that would be positive 4/3 x minus 6. The other one is y equals negative 4/3 x. And this one has a y-intercept right there of positive 2. Now, you may be saying to yourself, what happens if the sides of my box or my center are not on the y-axis? Then what do I do? If there could only be a shortcut. Well, there is. All of the asymptotes will be of the form y minus k equals plus or minus b over a, that's my slope, times x minus h. And h and k come from your center. Okay? The only downfall is you got to do it twice. You got to do it once for the positive and once for the negative. Okay? But that will happen when it's not.
Can you do it once to show?
Sure. Just to do it quick. Okay? So, let me see. Let me jump in here a page. So we had, our center was at what? 3 comma negative 2. And our slopes were plus and minus 4/3. Right? Okay? So y minus k equals plus and minus b over a times x minus h. So y plus 2, because it's minus negative 2, equals, we'll do the positive one first, 4/3 x minus 3. Right? Now we had just gotten this one as negative 6, correct? As my y-intercept. Okay? So y plus 2 equals 4/3 x. 4/3 times negative 3 is negative 4. Subtract 2 from both sides. Gets me the same thing. Okay? Then you got to do it a second way. And then, so y plus 2 is going to equal negative 4/3 x plus 4 now, because negative 4/3 times negative 3 is positive 4.
So y is the one that's always alone, because that's what you're kind of what you're solving for.
Called the point slope form of a line. Yep. Yep. And then there's the plus 2. Okay. So there's that. So there's our equations of our lines. Fantastic. Okay. Next, we have vertices. In a ellipse, where were the vertices? I need another word. No? Endpoints of the major axes. Okay, they were the endpoints of the major axes. Here, in a hyperbola, your vertices are going to be the midpoints of the sides of the box that it opens to. Okay? So since this was an x squared minus y squared hyperbola, that means it's going to open to the left and to the right. I need the midpoints of the left side and the right side of the box. So let's go back up here to the box. The midpoint is going to be straight out from the center to the left and to the right and on the side of my box. So this midpoint, so this vertex is going to be the point 0, -2. This one is going to be 6, -2. Agree? So the two vertices are 0, -2 and 6, -2.
If there was a case where it's an up and down one,
then you would go straight up and down from the center. So then that would be here and here. Yep. Yep. Okay. Good so far. Haven't really set the world on fire yet, right? So far, everything that we've done, we've seen at some point in time. Okay? Next, we can now draw our hyperbola. We'll go that way. So our hyperbola approaches our asymptotes, which is why we needed to draw those first, goes through our vertex, or our vertices, and it opens both left and right. Okay? Hoping I got everything. That way I don't have to redraw it. Math trick 101. Get rid of those. Okay. Last thing we have is we need to find the foci. Okay. So the important formula for the foci is a squared plus b squared equals c squared. Where have you seen that before? What? No! Because it was a squared minus b squared in ellipses. What kind of triangles? Right triangles. It's Pythagorean theorem. Okay? Alright? So a squared is the number underneath x. B squared is the number underneath y. C is what? No, what's C? What is it?
This is from the center to the focus.
Which was the same in ellipses, which was the same in, well, it was P. We called it P in parabolas. Okay? But yeah, so C is the distance from the center to the focus. And the focus is going to be inside the hyperbolas. Okay? So a squared in this case is 9. B squared is 16. So 9 plus 16 is 25. So c squared is 25. So what's c? 5. Take the square root of both sides. We get plus or minus 5. But since it's a distance again, we're going to go 5 in each direction. Okay? So since it's opening left and right, we get, or this gets added and subtracted to the x part of the center. Okay? So my focus here is going to be 5, 1, 2, 3, 4, 5 to the right of the center, 1, 2, 3, 4, 5 to the left of the center. So there are my two focus points. The center again was at 3, negative 2. So we're going to add to the x because it's left and right. So 3 plus 5 is 8, negative 2. 3 minus 5 is negative 2, negative 2. And again, if it were a vertical hyperbola, then we add and subtract that c value to the y part of the center. Okay? Just like with ellipses and c values, sometimes it's not necessarily going to be a nice number, and so then we would leave it in simplified radical form. Okay? And that, ladies and gentlemen, in less than a half an hour, is how you graph a hyperbola.